In the previous videos, we mentioned about the mathematical writings. We know that writing the mathematical equations within the technical papers is rather challenging, as constantly we need to swap between two languages. First is the text, the second it will be the formulas or equations. Formulas and equations are rather difficult to comprehend, especially in the first glance, as formulas and equations do not appear in our daily life or in our normal conversations. However, you know that formulas and equations is nearly inevitable in engineering research. There is a value to demonstrate the formulas, as it is a mechanism to concisely presenting a certain concepts, demonstrating the relationship between the parameters within the formulas and equations. And you will expect the readers, when come to the formulas and equations, they will have to read it very carefully, as every symbols within the equations carry some meanings. Proper definition should be given, and the respective background knowledge or working principles as demonstrated by the formulas or equations are to be indicated. As the mathematical writing is going to be incorporated in the normal text writing, there are some rules for you to make them nicely match. You will need to use the normal text to complement the limitations of the equations, which at the same time, the equations is also used to complement the limitations of the normal text. Therefore, you will have to use both in their own advantage in order to maximize the effectiveness and the purpose of the technical writing and delivery of the message. Out of the several rules that we have demonstrated in the previous videos, the ultimate goal here is to help the readers to understand and to avoid any unnecessary confusions within the readers. You will need to ensure the consistency, as well as overcome the complexity of the formulas and equations. The consistency may involve the consistency in terms of the usage of the symbol, as well as the sequence of the symbol being used. As for reducing the complexity, simple formulas, short equations are preferred, as compared to long and complex formulas. You know that symbols have some advantage of demonstrating the structures as well as the relationship between the parameters. If your formulas are constructed in a very complex manner, the respective structures of the equations may not be that obvious to the readers. Now let us proceed with other recommendations for the mathematical writings. Again, the ultimate purpose here is so that the readers can understand easily and to ensure that the message is clearly delivered. First, you will need to properly describe and demonstrate the derivation process, both conceptually and mathematically. Proper explanations and description is to be provided within the normal text, giving a directions how it is being derived, which at the same time, the derivations is demonstrated mathematically. This is to allow the readers to cross-check each other in case that they encounter some difficulty in comprehending either one of it. The reader can look into the other one to gain a better idea. With that, normally the descriptions in terms of the derivation process are to be placed closest possible to the mathematical derivations. It is so that the readers do not need to flick around the pages for parallel comparisons. You will need to properly describe all the symbols, providing proper definitions for those symbols, and normally the symbols are properly coded where the readers can observe the patterns as they read along your paper. You may need to complement with graphical presentation as well. This is so that the reader can imagine whichever that you are describing. With the help of the graphical presentations, the reader gains better ideas in terms of the relationship as well as the meanings of those symbols. Sometimes graphical presentations can give you more information, especially when you deal with the vectors, not only demonstrating the respective symbols, it also gives you an idea the directions of the vectors. Some examples of the vectors are the forces, displacement, velocity, accelerations, where all this, instead of the magnitude, there is also directions. In this case, graphical presentations will be useful. You should also clearly indicate the uniques as given by the symbols. This is to avoid the speculations of the reader in terms of the uniques as implied by the formulas or equations. Although in most cases, by looking into the components within the formulas or equations, the reader can more or less guess the uniques as indicated by the formulas or equation. This is going to be rather troublesome to the readers, and there are also circumstances, especially you deal with the statistical measures such as the regressions. Sometimes the relationship between two parameters is actually obtained from the best fit trend as observed from the list of the data comprising both parameters. Under such circumstances, the relevant uniques as implied by those equations and formulas, which are obtained empirically, are normally quite difficult to tell the actual uniques. In order to avoid the confusions, it is always a good practice for you to indicate the uniques. Sometimes there will be conversions in terms of the uniques. For example, Newton per mm square. Through some conversions, it can become kilonewton per meter square. By looking at the components of the equations, we know there will be combinations of the forces and area. We also know the structures in terms of the combinations. The relationship, it will be the forces per unit area as implied by the relationship within the equations, but it is sometimes difficult to tell whether it is in the mode of kilonewton per meter square or it is in the mode of Newton per mm square, especially when you need to use those units in the following derivations of the equations, or when you want to use those to compute the following results. To save the time that the readers trying an error, you just indicate the relevant uniques, and this will save the hassle for the reader trying to replicate your derivation process. And then you should use proper terminologies. You have to be careful with the descriptions or definitions of each symbols. Taking this as an example, the cross-sectional area is not the same as the contact surface area. You know that the cross-sectional area is the section area when the sections is split into half. However, if you are talking about the contact surface area, it is actually quantifying the surface area being exposed to something. Therefore, while writing the mathematical equations, you can always cross-check yourself with several recommendations here, which the ultimate goal here is to help the readers to understand better and to ensure the message is clearly delivered. Next, we talk about characteristics of good analytical study, which you know that analytical study are normally related with derivations of the equations, and then based on the equation derived, there will be discussions and finding. in order to extract more information from the analytical model. You will expect most of the engineering research will have this analytical study. Therefore, it is necessary for you to know the good characteristic in order to improve the quality of your technical writings as well as your analytical study. First, you need to be specific, and the analytical study needs to be custom-made for your project. Because your ultimate goal here is to solve a problem. The research study itself is unique, specific, which is actually custom-made. Same should go to your analytical study. Everything should be straight to the point. Those which is not relevant to your project, you do not need to spend effort explaining the heads and tails. Everything will directly refers to your project. Next, a good analytical study should have the derivation process to be logical and conceptually correct. It should be presented in the manner that it is undeniable by the reader. You know that the mathematical derivations is actually carrying the informations reflecting the relationship and transformations of the concepts. The derivations normally start with the first principle. The derivation process is actually reflecting the formulations, transformations, and the evolutions of the concepts. And the outcome of the derivations, it will be the finalized concepts which has been established after synthesis of different principles as reflected by the derived equations. Therefore, its derivation process should be concurrent with the changes in the concepts, which must be concurrent and also logical. As everything, it will be on basis of the concepts and principles. Also, there should be clear boundaries or assumptions made by the analytical study. Those boundaries and assumptions are the main reason leading to the outcome of your analytical study. In the case that slightly different assumptions are used, the final outcome may vary. Therefore, you should clearly indicate the boundaries and assumptions made within the analytical study. Another reason is that normally the analytical study is trying to study an actual situations, which is rather complex, comprising so many factors, where the amounts of the factors are normally beyond the manageable level for a typical study, and sometimes it could be the accumulations of several minor factors leading to certain outcome, which if you quantify one by one each, you may not be able to see the significance. And when the significance is low, those parameters or factors are normally ignored in the analytical study. Some may even not be known by the existing theories and principles that the parameters is actually to some extent contributing to the outcome. Out of so many uncertainty, it is normally that researcher will simplify the analytical model on basis of certain assumptions, which itself could be massive enough to become an independent study. Therefore, the assumptions and boundaries is important. In the case that there are limitations in terms of the analytical study, those limitations needs to be clearly identified. The reader should be aware of the limitations of the study so that they don't misuse the findings as acquired from the study beyond the applicable range as recommended by the researcher. Next, your analytical study should be thorough and it should cover all the critical aspects. Your study should be able to identify the significant factors contributing to the response so that the readers have a clear picture in terms of the cause and effect relationships. And then, a good analytical study should have a strong linkage between the test specimen, concept, and equations. You know that the equations and the concepts they are running parallelly in concurrent manner. The transformations of the concept will be reflected in the derivations of the equations. And then all these have to be on basis of your test specimen, which in most cases, the test specimens are used to verify the equations. Therefore, you can perceive this. The test specimen, concept, and equations are three lines running parallel, talking about the same thing. You will use all this to cross-check each other to ensure the validities of every single one of them. It is only when you acquire the validity, you will evaluate the reliability and accuracy also. And then only all these have proven satisfied, then whichever outcome that you have acquired from your analytical study, the observations, the findings, can only be considered reliable. Next, your derived outcome from your analytical study needs to be adequately verified and validated. Without proper verifications and validations, the analytical model will remain as a model, which their correlations with the actual situations may be questionable. You know that what you are actually doing is to study the analytical model in order to understand the actual situations. But if the models is very much different from the actual situations, the model becomes meaningless, and the finding as acquired from the analytical study may not be able to explain the actual situations that you are studying. Next, you will need to review the derivation process and relationship between the parameters for new insight and findings. You know that a good analytical study is not just deriving the equation model. The derivations is one significant part. Then after the derivations, you will need to check for the validity, reliability, and accuracy of the model. And then after that, the analytical model is actually representing the actual situations that you are studying. Your ultimate goal here is actually to understand the actual situations, where your analytical model is actually a tool or an approach for you to understand the actual situations. Therefore, you should not stop after you have acquired the model, which you have to elevate further in order to extract insights and findings based on the analytical model in terms of the relationship between the parameters as well as the derivations process. This is another main part of the analytical study, which comes after the derivations and the verification process.